Good morning everyone. In the last video we have discussed some of the method for the purification of the colloids as well as some of the properties of the colloid. The method for the purifications were the electrodialysis and the ultrafiltration, and the properties which we have discussed about the colloid was the Brownian motion as well as the Tyndall effect. Here today we are going to discuss about the electrophoresis and how the electrophoresis explain about the stability of the colloid. See, in this electrophoresis, what is the arrangement? There is a glass tube which is a U-shaped tube which have two electrodes. One is positively charged and the next one is negatively charged. And in this U tube, when you will see, the U tube is filled with the colloidal solution. Colloidal system. These are the colloidal particles and remaining are the liquid particles. I have tried to show it. What actually happens when you will provide the charge? We can see that the oppositely charged particles or oppositely charged system will attract each other. It was taught to you by the lower class teachers, or even in the higher class the same thing is taught to you, that opposite charges attract each other. So surely that will happen here. Even sometimes the neutral species are also attracted by the charged one. So when we started the charge, when we connected the system, what happened? We find that all the colloidal particles starts moving towards a specific pole. In this case, you can see that all the particles are moving towards the positive pole. So when we started the circuit, we find that all the colloidal particles are moving towards a specific pole, in this case towards the positive pole. What does it mean? It means that all the colloidal particles are identically charged. And in this case, all the colloidal particles are negatively charged. Sometimes they are negatively charged, sometimes they are positively charged, depends upon the different colloids. So here it is negatively charged. Whether it can explain the nature of the colloids. We knew that the colloids are the stable but heterogeneous system. And if they are heterogeneous, surely their concentration on the top becomes a little lesser and that becomes greater on the bottom. What does it mean? Surely these are the particles are slowly but surely moving downward. And if they are moving downward, it means after a period of time the instability will take place. एक सिंपल सा एग्जाम्पल देखिए, घर में जब आपके फ्रिज में दूध रखा रहता है रात का, अगर उसके ऊपर से मलाई हटा दी जाए और मॉर्निंग में उसे देखा जाए, व्हाट हैपेंस? You will find that your milk is carrying maximum water. लगता है पानी ही पानी उसमें है. But when you boil the same milk, what happens? You will find that the concentration of milk is as it was in the evening. What was the actual condition? Actually, the solute particle, that is called the dispersive phase in the case of the colloidal system, the dispersive phase was going to be suspended. वो धीरे धीरे सस्पेंड हो रहा था. And when you boil the material, due to the excess of the velocity of the molecule, the restabilization of colloids takes place. It is suggesting that the colloidal particles are such heavy molecules, such heavy particles, that they are just in the range to hold the particles, or you can say they are just dipping down slowly. Now if you assume that this is the colloidal particle, this hand is the colloidal particles and this is the another colloidal particles. If they have the opposite charges, if this one is positively charged and this one is negatively charged, if they have the opposite charges, then when they will approach, they will make a system which is bulkier one. Already the particle was heavier and that was dipping slowly. If the size of the particle will become greater, the mass of the particle will become greater, what will happen? The system start dipping rapidly. That is, the destruction of colloid will take place. But what actually happening? According to electrophoresis, it is saying that all the particles are identically charged. And if all the particles are identically charged, this one is positively charged and this one is again positively charged, when they will come in contact of each other, the identical charge repulsion will act there. And if the identical charge repulsion will act there, what will happen? They will just move away from each other. And if they are not combining with each other, they are not going to increase the size of the particles, and if they are not going to increase the size of the particles, surely they will become a little more stable than in the case when they are combining with each other. Then the identical charge is suggesting that the colloidal particles never combines with each other to make the giant particles, and as a result the colloidal systems are stable. Then the electrophoresis suggests, what is the electrophoresis? When you will ask, then you will say that the electrophoresis is the process in which when we put a colloidal solution in a U tube and pass a current, we find that all the colloidal particles move towards a specific pole. And that is suggesting, the process suggests that all the colloidal particles are identically charged, and this nature of the colloidal system suggests the stability of the colloid. So in this way, on the basis of the electrophoresis, you can say that colloids are stable because of the identically charged particles. Now we are going to see the next topic, and the next topic is the coagulation. What is coagulation? When you will discuss about the topic coagulation, we see the process of destruction of colloid is called coagulation. What is the destruction of colloid? The suspension of colloid is also known as destruction of colloid. Then how the coagulation takes place? Whether there is any specific method for the coagulation or some of the other methods are also there. The best method for the process of coagulation is just to add some of the electrolyte with the colloid, and you will find that the colloidal system will suspend down, the colloidal system will coagulate. You can see at your home, just make a colloidal salt. You can make it by mixing the soil with water. You can make it by mixing the starch with water. And after making this one, just add a little amount of alum potash with your mixture, with your colloidal system. What will you find? You will find that all these of the soil particles which were making the colloidal system, they will suspend down. In some of the zones in India where the pure waters are not available, we use the same method for the process of decantation, with the help of which we can purify the water. Even in some of the big cities where the water supply is taking place with the help of some of the rivers, we are taking water from the rivers, then the river water is also in the colloidal form. Some of the mud particles, some of the soil particles are suspended or the mixed with these of the system. So we need to remove these of the mud particles, these of the soil particles, and for the process we use the same method, that we add the alum with it, and we find that these of the materials get suspended, and we find the soil free, dust free, mud free water, and then we purify with the other method and find the drinking water. Then this is the process of coagulation. Then the first method is just to add the electrolyte. If there is any other method, surely there is some other method which can be used for the process of coagulation. The second one is to mix the oppositely charged colloid. If one colloid having colloidal particles nature positive and next colloid having colloidal particle nature negative, that means the positive and negative charges. If they have the oppositely charged particles, then if you are mixing these of the two systems, what will happen? These of the particles will attract with each other, will make the bigger molecules, and as a result the suspension will take place, as a result the coagulation will take place. We have already discussed in the case of the electrophoresis. So after mixing the oppositely charged colloid, we can coagulate a solution by the continuous dialysis, which is called the persistent dialysis. When you will go for the persistent dialysis, almost all the electrolytes will be removed, and in absence of electrolyte, or in the process, in the condition of the complete removal of electrolytes, we will find that these of the colloidal particles are not stabilized, they are also getting suspended. Then these are some of the methods which are used for the process of coagulation, which are used for the suspension of the colloids. So here these were some of the properties of the colloids which we have seen. The first property was the Brownian motion, second one was the Tyndall effect, then electrophoresis, then coagulation, and some of the properties we haven't studied, which was in the category of the first one, that is called the colligative property: elevation in boiling point, depression in freezing point, lowering in vapor pressure, etc. So these were some of the properties of the colloids. Now we are going to discuss the another type of the colloid, a unique type of the colloid, which is called the emulsion. And we will study about the emulsion in our next video. Till then, bye. Have a nice day. Thank you.